So we are going to be determining how to calculate or how to find the area between two curves in this presentation. So let's go ahead and write down the instructions. The task is to find the area of the region enclosed by the given curves. Okay, so for question 1, let's say we have two radical functions. So let's say f of x equals 2 root x and g of x equals 3 times the square root of x, and then we have two vertical lines, x equals 0 and x equals 4. Okay, so we are going to find the area between these two curves bounded by these two vertical lines. Okay, now before we get started, let's give ourselves a visual of what the two curves and the resulting bounded regions look like, and then we will proceed from there. Okay, so the assumption for this problem is that you will be provided with the graphs of the regions you're to compute the area of. So that's not a requirement here. Okay, so the first one is a radical function. Let's say this is say 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. Okay, so the first one goes through 4 and 4. So we want to graph the first function. Let's say you have a function, let's make it blue. So this is the first function you're given, is this radical function f of x equals 2 root x, and then you have another function. Let this be the second function, 3 root x. So at 4 we have, instead of 4 you have 5 and 6, and then you have the second function given. Let's do that again. And then let's say the second function you're given, g of x, is going to be 3 root x. And then you have the vertical lines you're going to have to consider. Let's put those in red. And then you have a vertical line here. This is the right boundary. And then you have another vertical line here, which is the left boundary. So let's just assume that you're in this problem you're given the graph and the functions. Okay? Your task is to compute the area of this region right here. Let's call it R. This enclosed region between these two functions. Okay? Alright, so how do we do that? Let's go ahead and put in some numbers. This is 0 and this is 4. Now what you notice is that this function is a top and down orientation. You have a function on the top and a function on the bottom. So let's call this f top and this one f bottom. Now since we have an up-down configuration, that will help us determine the right formula to use. Okay, so let's go ahead and write down the formula that will guide our problem solving process. So the formula for finding the region bounded by two curves oriented vertically is, the area is going to be the integral from a to b of the function on the top minus the function on the bottom, and the variable of integration is the x, since we're going towards the x-axis. Okay, so remember we're going downwards towards the x-axis. That's why everything is going to be x. All right, so let's go ahead and identify our top and bottom functions. F top is already specified. F top is the function that's on top. Okay, starting from the x-axis, imagine this is the ground level and you're going upwards. So the function on top is 3 root x. And then the function on the bottom is the other one, 2 root x. Now for your a and b, you're going to be going from left to right. Okay? So the left boundary is your a and the right boundary is your b. Alright? You're going in increasing order. So a is 0 and b is the right boundary, which is 4. Alright, so let's substitute all these values into the area formula and compute what the area is. So the area is going to be the integral from 0 to 4 of f top, which is 3 root x, minus f bottom, which is 2 root x. And then we're integrating with respect to x. Alright? Now we're going to use our power rule to evaluate these two integrals. In order to use the power rule, we have to express these two integrals as powers. So this becomes the integral from 0 to 4 of 3x to the 1/2 minus 2x to the 1/2 dx. Okay? And then you have to remember your power rule. Remember that when you're integrating x to the n dx, you're going to have x to the n plus 1 over n plus 1 plus c. This is a definite integral, so the c's cancel out. We're not going to have the c component here. So let's go ahead and apply this power rule for integrals to this particular example. If we apply it, we're going to have brackets. Now, as soon as you integrate, this integral sign is gone. Okay, as you integrate. So this becomes 3x to the 1/2 plus 1. But I'm going to write 1 as a equivalent fraction with denominator 2, which is 2 over 2. Okay? And then that divided by 1/2 plus 1 plus 2 over 2 also. Okay? And then minus 2 x to the same procedure applies here. We have 1/2 plus 1, 1/2 plus 1, which is 2 over 2, divided by 1/2 plus 2 over 2. Okay, and then we are evaluating this from 0 to 4. Okay, so let's go ahead and simplify. We're going to have, this becomes 3 to the x to the, if you combine that, you have 3 over 2 over 3 over 2 minus, and then 2x to the 3 over 2 over 3 over 2. And then that's being evaluated from 0 to 4. And then we just drop change flip, okay? So this one, you drop change flip, you have 2/3 times 3 x to the 3 over 2 minus 2 times 2 over 3 x to the 3 over 2, and then we're evaluating this from 0 to 4. Okay? Alright, so let's go ahead and simplify that. If we simplify that, we're going to have, what are we going to have? We're going to have, these 3's cancel out. So we have 2x to the 3/2 minus 4/3 x to the 3 over 2. evaluated from 0 to 4. Alrighty. And then what we'll do next is just plug in the lower limit minus what you get when you plug in the upper limit. So when you plug in the lower limit, the upper limit goes in first. The upper limit, you have 2 times 4 raised to the 3 over 2 minus 4 over 3 times 4 raised to the 3 over 2, and then that times minus 2 times 0 raised to the 3 over 2 minus 4/3 times 0 raised to the 3 over 2, like that. Okay, so let's go ahead and simplify. If you raise 4 to the 3 over 2, what you're doing is you're taking the square root and raising it to the third power. Okay, so you can think about this as 2 times the square root of 4 raised to the third power minus 4/3 times the same thing, the square root of 4 raised to the third power. And then these are, if you raise anything to 0, if you raise 0 to any power, it's always going to be 0. So this entire thing here is just going to be 0. Okay? So the square root of 4 raised to the third power is what? Square root of 4 is 2. If you raise it to the third power, that's 8. So 8 times 2, so it's 2 times 8 minus 4/3 times 8. And then you have 16 minus 32 over 3. And then we find the LCD, put this over 1, and then times it by 3, top and bottom, times it by 3, times it by 3. And then what are we going to have? This is going to become 48 over 3 minus 32 over 3. 48 minus 32 is 16, so our final answer is going to be 16 over 3.